wanted this presentation to be like Indiana Jones, like super exciting and spelunky and stuff, except apparently I'm really short on time, so I'm going to have to make it a bit like the Wizard of Oz, meaning imagine Indiana Jones wresting a kettle out of Dorothy's hands in Kansas. Like 7 extra minutes for this. Should do more of that. So most of the relevant parts about me have already been told. Basically, written Go for the best part of ever since it came out. And I really, really like it. I have a couple of tools under my belt that I've written by my old self, and that basically I'm the only use case for. And I really, really enjoy reading source code, which I think is a super important way of learning about everything that works on the internet, especially in the case of Go. And that's basically what I'm taking you through today. First things first, we're going to be exploring a bit of net HTTP. I gutted a bit of that part earlier. Should still contain interesting parts. There will be source code, I promise you. Then a very, very short list of packages that work well with net HTTP. And then I have a super short demo of something that I think is interesting because it's short and it works, and I really didn't write much code at all for it. I'm depending on a lot of stuff, but that doesn't really matter. So net HTTP, I'm going to be interested more in the server side of things because that's my job. I write services. I write backend code. I'm really bad at pretty stuff. So enter net HTTP server side. I'm going to talk a bit about listen and serve, the handlers, and then the stuff that you get for free from the standard library, which you'll see it's much longer than the rest of this page. Okay, so important parts about listen and serve. Main entry point for Go services. Everybody, I expect, is using it pretty much all the time. Accept an address, which I don't really care about. The thing that clicked a bit too late for what I care to admit is that you don't actually need a request multiplexer. You can pass any kind of HTTP handler to that function. So if you're into microservices and you just have your one tiny super efficient handler, you can just shove it through the listen and serve thing, and it's going to work just fine. Don't need to make no routes or stuff. The HTTP handler, most of you, I'm not going to take assumptions. Some of you may be familiar with the handler interface that basically requires you to implement a function called serve HTTP. Takes a response writer, which is what you use to write out to the other guy, and request, which is what you received from whoever's trying to talk to you. There's a companion function type called handler func. Basically, any function that has the same type signature as serve HTTP can be typecast to handler func, and then it magically becomes a handler interface because the handler func type implements on the function type a serve HTTP function that just calls the function that you typecast it to. That makes a lot of sense in my head. The source code is much, much clearer than I. So basically, this is in net HTTP, and what happens in this function is just f writer reader request. So that's the end of that. Pretty awesome. So if you have a function somewhere, you can just typecast it and pass it to the listen and serve thing, and it's just going to work fine, which is awesome. So response writer, some of you may know, can be upgraded because in the net HTTP package, it actually implements diverse other interfaces that may or may not be of interest to you. For example, the hijacker that I personally will never use allows you to grab the underlying TCP connection to whatever it is you're currently responding to, and just do plain TCP. So, for example, a guy could call you, and you say, well, from now on, we're just going to speak normal TCP, and you expect the guy to write stuff, and you can have request responses, telnet style, right there in an HTTP request. The flusher enables you to write the data immediately to the response writer, which is probably useful if you're going to stream long stuff that you want to start going out the wire immediately. And then one of the most interesting ones that I think is the close notifier, which will, if the underlying connection goes away, allows you to cut whatever work you're doing. So if you have expensive computations to run and the connection actually stops being connected and you don't need to do the work, you can just free your CPU to do more important stuff. List of stuff you get for free with NetHTTP. On the server side, you got concurrent requests, super efficient file sending. I'm not sure about Windows on that one. You get HTTP2 for free, diverse HTTP utilities, including testing tools, and profiling. On the client side, you get a pretty solid HTTP client with cookie support. And in the subrepos, you also have OAuth2 and JWT support, which is pretty important for people like me who are writing services and stuff. Mostly and stuff. So concurrent requests. Basically, this is I removed some code, some handling code in there, but basically, once the stock HTTP server accepts a connection, it does a bit of work, and then it just fires it off in a Go routine. So you don't even have to worry about your HTTP request being concurrent. They're going to be from the moment you use the standard library server that you're given. So I think that, well, it's super powerful and super interesting that you actually would get that for free without any kind of headache whatsoever. Super efficient file sending. So net HTTP server, in that file, the response actually implements read from. Taken from the comment, because I knew it was doing that, and I was searching specifically for that comment and did not really read past the comment. I trust them. Basically, it's going to use send file in order to, when you're doing something like io.copy, in order to not have to pipe the file in user space before sending it to the response. Yeah, I'm just going to reword this a bit. Basically, usually when you read a file in memory, it has to go to user space. Using send file allows you to send a file directly on the wire from the kernel, which is more memory efficient. You guys may remember this feature from Nginx. So yeah, send file, I explained it, yay. If you did not know that what is existed, now you do. It's pretty sweet. You get to see in a very short line what a thing does. So yeah, basically the only problem with send file is it doesn't work with SSL unless you're running FreeBSD, because Netflix really needs send file to be able to perform okay. And recently they actually pulled in a patch or pull request, or however FreeBSD does their stuff, so that they could actually use send file even though they were using also SSL, which I think is really cool of them. Starting from Go 1.6, yay Go, you get HTTP2 for free enabled by default on SSL connections only, which is good because that's pretty much what it's about anyway. So request multiplexing, preemptive asset pushing, and stuff like that, you all get that for free, and you don't even have to think about it, just as long as you're using Go 1.6. Marvelous. HTTP utilities. There's a thing called net HTTP util, and it contains many packages, many functions to do stuff like dumping requests, dumping responses, which is super useful in debugging. It has what you need in order to build a reverse proxy. Most of the rest of the package is marked as old, and they outright say in the documentation that you shouldn't use it because there's other stuff at HTTP that has superseded those functions. It's super cool because it contains really important stuff to test your HTTP services. There's also HTTP test, which contains utilities to test your HTTP services, which I find really cool. 10 minutes in, I'm probably going to be short, which is good. So a profiler, right? Everybody likes a good profiler. It comes in the package. You don't have to work for it really hard. You actually, if you're not using the, no, I was right the first time. If you're using the default servmux, you just have to import the net HTTP prof package, and it will do magic for you behind the scenes, mapping routes and stuff like that. So, okay, if I do run, hopefully it doesn't blow up. I have this tab open. I'm cheating. I'm sorry. So if you look at the heap, for example, I can see this. You'll see this localhost 6060. That's actually the, well, you can see it now, but it's actually running off my computer. And if I update it, you'll see the numbers changing. Oh, wait, maybe you're not seeing because I have a weirdly low font size. I'm sorry. So yeah, basically this is all running off my thing, and I didn't have to do anything special to plug it in to actually know what my Go routines running are. It's right there for me to reap. No work. I like no work. Work lazy, not hard. So that's that. And then yeah, packages that work well with net HTTP. Basically, all of these are, I think, super useful. I'm going to touch on OAuth 2 in a bit, but there's, for you to grab, there's server-side JWT, client-side JWT, and by the way, this thing here, the client-side JWT, that's part of the sub-repos. It was written basically, I guess, by the same guys who own the golang.org domain, which I hear is probably Google or something. So yeah, this comes for free, and it's important if you're doing OAuth 2 with client-side JWT, because Google uses that, apparently. Graceful restarts, apparently Facebook Go has graceful restarts, which is super useful if you actually want to have zero downtime deploys. I've been using that specific package for a while, and it works great. Basically, it packs file descriptors after having forked a thing, so that you just don't have to close your HTTP connection. You finish serving the connections that are coming in, you open up the other thing, and it magically goes through without, hopefully, 500 errors because your server has gone away. And then Interpose is a super cool minimalistic middleware structure that is actually following the interfaces declared by NetHTTP. That means that there's no magic. You can just pull this in and start writing your middlewares and stuff, and it's all going to be standard with the NetHTTP interfaces, which I think is super important. So on with more code, bit more code. So for this specific purpose, I've written a simple OAuth 2 dance thingy, which basically grabs you from the root of where you're accessing this, pushes you to whatever endpoint I configured, in this case Google, but I also did GitHub, it works fine. You're going to say, well, yes, of course, you're allowed to take all of my data and forward it to the NSA and stuff. And then it's going to return to a callback URL, persist it momentarily in a local database, and redirect you to root again, which will pull some of my personal data from Google+. So yeah, this part here, as you can see, can you see okay if I select my things? Yes? No? Maybe? Anyway, so yeah, basically, if there's no cookie in the beginning, I do a thing called OAuth dance, which is much less fun than the time warp, which simply does grab the config that I set and redirects the user to the proper endpoint. In turn, it's going to go back to callback, which does a bunch of error handling, and then just stores the cookie temporarily, as I explained. And when you go back, it just does a GET request to me. And hopefully this will work. I think it's already ready. So again, sorry for my freakishly small fonts. I'm just going to allow it. And you can see all my personal information in front of your very eyes. And that's pretty much that. So I believe I have 5 minutes left for questions, which is more than I could have hoped for. I also can be reached at any of those places. The slides for this presentation will be up on my GitHub account shortly thereafter. Any questions? Yes?
And what are your feelings about putting a Go server exposed directly on the internet instead of putting like a reverse proxy like
oh, right. So he's asking how I feel about exposing a Go server directly to the internet, and I have mixed feelings about that. The reason why I have mixed feelings about that is mostly I'm paranoid for no good reason, because there's crypto baked in, and you can do SSL right in, and it seems to be fairly safe. But I don't want to be the one who got like destroyed because I exposed it. So I don't. But I hear people have done it with great success. So I don't see a reason why you shouldn't do it, except being paranoid like I am, which I must stress that I'm very paranoid about that. Any other question? Yes, in the back. I think I frankly haven't tried it. I'm like pretty sure there's a way to make it work, because it's actually just using the send file call. So I don't know how to configure the bulk encryption thing. It's fairly recent and I haven't played with it, but I feel that if you're plugged to the right pipes, it's probably going to work out of the box pretty much. Just finding the right pipe.